two cars leave the same location at the same time. One is going due east, that's our blue car, at 60 kilometers per hour. The other is traveling due north at 45 kilometers per hour. How fast are they separating? So as they travel along those paths, they are going apart from each other faster and faster, so that their walkie-talkies eventually are not going to work anymore. At 2 hours, we want to know how fast they're separating. How fast are they going apart from each other at 2 hours? Well, what we have here is a right-angled triangle. What kind of equations can you make with a right-angled triangle? Yeah, you could use, I'm going to use x, y, and z. I could use a, b, and c. But we got our Pythagorean theorem, right? And our equation for that is x squared plus y squared equals z squared. I'm going to just move that down, because if we're going to write things out the same way that we have before, what do we know in this equation? We know dx dt. We know that that is traveling at 60 kilometers per hour. We know dy dt. That's traveling at 45 kilometers per hour, and we want to find how fast they're separating. We want to find dz dt. That means that your x is a function of time, your y is a function of time, and your z is a function of time. And we know that a squared plus b squared equals c squared, or x squared plus y squared equals z squared. So we can take our derivative with respect to time of this whole thing. What's the derivative of x squared? Go back to my color. It's 2x dx dt, right? Plus derivative of y, 2y dy dt. And the derivative of z, 2z dz dt. Well, do we know everything in this situation? Now that we've taken the derivative, we want to find dz dt. So in order to solve this, we need to know dx dt and dy dt, which we do, and we also need to know x, y, and z for them. At 2 hours, let's draw the triangle. At 2 hours, how far has the blue car gone? 120. At 2 hours, how far has the green car gone? 90. At 2 hours, how far apart are they? Quick mental math. 90 squared plus 120 squared is? Square root that. Square root of 22,500? 150? I didn't actually do 90 squared, which is 8,100 plus 1440 and add 14,400 and add them up to get 22,500. What did I recognize? This is just a 3, 4, 5 triangle, right? Divide by 30 and get 3, divide by 30 you get 4, divide by 30 you get 5. It's dirty. So now we know at 2 hours this is the distances in between them, so we can do the following. 2 times 120 dx dt was 60, plus 2 times 90 dy dt was 45 equals 2 times 150, and dz dt is what we want to find. Simplify all of this. Looks like just a little bit of mental math. And we get 75 kilometers per hour, which is an interesting result. It's interesting because if you divide 45 by 15, you get 3. 60 by 15, you get 4. 75 by 15 is 5. Makes you wonder, could I have just done a squared plus b squared equals c squared with my rates of change to begin with? The answer is yes. It would have worked if we would have just done our rates of change squared, because you're dealing with the same units and all three of them are changing. You could have done that for this question to begin with. But we will have right-angle triangle questions where certain things don't change. So only if all of them are changing at the same time could you actually just do this squared plus this squared equals that squared. Okay? Why does that work? You can kind of see why that works here. Because what is, right? Well, first of all, can you see that your 2's could go away? You could divide everything out by them. And all x is this 120. That 120 is 2, which, let's say I change the time to something, instead of after 2 hours, something miserable, like after 2 hours and 23 minutes and 45 seconds. Ugh. Right? Imagine having to change that into some sort of number. But all this is your time multiplied by your speed, which is dx dt. Right? That's what that 120 is. Would you agree that your 90 is your time times dy dt? And your 150 is your time times dx dt. So I'm going to just give a proof why you were allowed to do. You don't have to write this down or anything, but if I erase this and instead included the 2 and instead of the x I wrote time by dx dt, dx dt, plus 2, and instead of the y I wrote times dt times dy dt, equals 2, and instead of the z it would be time times dz dt, dz dt. What does this prove? Can you see that all those 2's would have canceled out? All of your times would have canceled out. And you get the equation that dx dt squared plus dy dt squared equals dz dt squared, which is just a squared plus b squared equals c squared. So you could do that as a shortcut for all questions that are right-angled and all three sides are spreading out at the same time. Okay? But we're going to look at some questions where one thing is fixed. So these ones I would say are easy right-angle triangle questions, level 1 right-angle triangle question. This one is an easy right-angle triangle question, one that's identical. You could do a squared plus b squared equals c squared for this one. It's so much the same as the last question that I'm going to skip it. And we're going to go on to one that's different. A 20-foot ladder leans against a house. So we have to draw a house, skinny house, very nice. The door down here, window up here, beautiful. And we've got our ladder that's 20 feet long, leaning up against that house. Okay? The ladder is sliding down the house, okay? And it's moving away from the house this direction 2 feet per second. That's what's happening. So it's sliding down the house and away from the house. It's slipping, it's falling. Find the rate at which the top of the ladder is falling down. So we want to find out this, dh dt, when it is at 12 feet. So let's say there's a window here. You're sticking your head out to see what's happening, and you don't realize that ladder is coming down, and you want to know how fast is it going to hit you in the head at that moment. Right? You quickly turn up, do all those mental math calculations to see if I don't stick my head back in the window, it's going to hit. What is it going to feel like? Right? Because that's probably what you would do in that situation. Freeze and do all the mathematics you can. Okay. So what does this mean? We've got to set up some variables here. We've got our triangle, and in our triangle, this is x, this is y. Those are the two things that change, but our z this time is always 20. What do we know about this triangle? We know that x squared plus y squared always has to equal 20. We want to find out how fast y is changing, how fast it's moving downwards. What do we know about x? X is getting bigger. Yes, thank you. We know that x is getting bigger at 2 feet per second. We want to find this at y equals 12. So we know that both x is a function of time and y is a function of time. Why isn't z a function of time? Because z is always 20. It's constant. So now that we have this set up, and we take our derivative with respect to time of each of those things, we're going to get 2x dx dt plus 2y dy dt. And what happens when I take the derivative of that 400? I get 0. Now, in particular, now we have to say we want to find dy dt. So what do we need to know? We need to know dx dt. Well, that was given to us. It was 2. We need to know y, and we need to know x, and we were told when y is 12. So what we're looking at is this specific triangle where this is 20 and this is 12. How do we find x in this specific triangle? We do a squared plus b squared equals c squared. Do you recognize it? Can you see what the answer is without doing major complicated calculations? I'll wait. I'll plug in everything else, and you can calculate it. 2 times something, which I'm not telling you what it is. dx dt is 2, plus 2 times y is 12. dy dt is what we want to solve for. Has to equal 0. What is the x here on the bottom? Close. 16 makes a 3, 4, 5 triangle. See, if you divided the 20 by 4, if you divide the 20 by 4, you get 5. So 12 divided by 4 gives you the 3. So you need a 16 there to get your 4. Right? And you're very thankful at this moment as the ladder's coming down that, oh, I'm glad it's a 3, 4, 5 triangle that I can do this mental math better, quicker, before this ladder hopefully hits me in the head. So this is going to be 16. Yeah. Hypotenuse. That's right. Because you could lay it flat or turn it around or move it however you like. So we're going to have 4 times 16, 64 plus 24 dy dt equals 0. So move your 64 over to the other side. Divide by 24. And this simplifies nicely to, divide them both by 8. Ooh, that's a fancy y. dy dt is negative 8 over 3 meters per second. It's feet per minute? Great. Feet per second, thank you. Why is it negative? Because it's going down. If we think about, and this is going to be important, when we think about our original triangle here with our 20, our x, and our y, the way that we drew that and the way that the ladder is moving, your x is increasing. Because as it slides down, x gets bigger. So your dx dt has to be a positive 2. Your y is getting smaller. That's why your dy dt has to be negative. Yes?
Wouldn't x be 12? It said the foot of the ladder is 12 feet from the house.
Oh, yeah. X would be, so everything needs to just, you just have to do this. There we go. Thanks for noticing that. It just makes everything miserable here. Doesn't change too much. That just makes this 48 plus 32 gives us negative 48 over 32, which reduces to negative 3 halves. So we could have solved it either when it was 12 feet above. I like the story better because I can imagine a window 12 feet above with the head sticking out. But yeah, the question says when the ladder is 12 feet away from the building, then it would come out to this. So that one's a little bit harder just because the 20 stays constant. I don't know if it moves it from an easy to a level 2. I'm not sure, a medium one.